Assalamu alaikum guys, I am Asghar and in this video we are going to discuss our next topic. So let's move towards our topic without any further delay. Our today's topic is the second condition of equilibrium, as you can see at the top of your screen written in the green color. Actually I have already uploaded a video on the first condition of equilibrium. So if you want to watch that video, then you can simply go into the iCard and watch that video. Anyways, let's discuss second condition of equilibrium without any further delay. In order to understand this condition of equilibrium, first of all, we shall have to understand its definition. So let's study its definition. Its definition is the vector sum of all the torques acting on a body at any arbitrary axis is equal to 0. Here we have noted 3 points. The first one is vector sum. Actually, the addition of vectors is known as the vector sum. And there are two methods for vector sum. The first one is Pythagoras theorem and the second one is head to tail rule of vector addition. And the second point which we have noted here is the torque. Actually, torque can be defined as the turning effect of the force. Mathematically, it is the product of the force and momentum. And arbitrary means the random. And arbitrary axis means any axis. Means we can take any point as the axis. There is no any specific point which we shall take as the axis. Mathematically, this condition can be expressed as tau 1 plus tau 2 plus tau 3 plus tau n is equal to 0. Here, tau 1 shows the first torque, tau 2 shows the second torque, and tau 3 shows the third torque, and tau n shows the any number of torque. And this expression shows that the sum of all these torques is equal to 0. In the next step, we shall write sigma tau is equal to 0. Here, sigma is a mathematical sign which is used for the summation. Tau is the symbol of torque. Here you can see that I have bolted the tau, which shows that the torque is a vector quantity, not a scalar quantity, because bolted letters are used to show the vector quantities. Here you can see the diagram when first condition of equilibrium is satisfied, but second condition of equilibrium is not satisfied. In this diagram you can see a rectangular object on which two forces F1 and F2 are acting. These two forces are acting in opposite direction with respect to each other. If both these forces are of equal magnitude, then they would cancel out each other and the resultant force shall be zero. So the body will be in translational equilibrium. But you can see that these forces are not acting along the same line of action. So the body has tendency to rotate. You can also say that the body has not linear acceleration, but the body has the angular acceleration. And you can also say that the body is in translational equilibrium but not in the rotational equilibrium. Here you can see the diagram when both the conditions of equilibrium, I mean first and second condition, are satisfied. In this diagram you can see a rectangular object on which two forces F1 and F2 are acting. These forces are opposite in direction with respect to each other, and if they are of same magnitude, then they would cancel out each other and the body shall be in the equilibrium. So the body will be in translational equilibrium as well as the rotational equilibrium. It would have no linear acceleration as well as angular acceleration. Now we are going to discuss the requirements for a body to be in complete equilibrium. I mean such an equilibrium in which both the conditions of equilibrium, I mean first and second, are fully satisfied, and the body has no linear acceleration as well as the angular acceleration, and the body is in translational equilibrium as well as the rotational equilibrium. So here we have 4 points. We shall discuss them one by one. Our first point is sigma f is equal to 0. Our second point is sigma fx is equal to 0. I mean the sum of all the forces acting along the x component is equal to 0. Our third point is sigma fy is equal to 0. I mean the sum of all the forces acting along the y component is equal to 0. Our fourth point is sigma tau is equal to 0. I mean the sum of all the taus should be equal to the 0. So it was our discussion of today. Now I will see you in my next discussion. Till that, Allah Hafiz.